Hello guys, welcome to my YouTube channel IB Chemistry of the AF, and today I'm going to talk about Unit 2, to be specific 1.2, and let's begin. So for this unit we need to know specific definitions such as atomic number and as well mass number. So if you have an element, we have, for example here, the mass number is the sum of protons and neutrons, while the atomic number is just the number of protons. Okay, so an atomic number is the number of protons in the nucleus of an atom, and protons are one of the three main subatomic particles. On top of that, they're also positively charged, and as well in a neutral atom, the protons are always equal to the number of electrons. On the other hand, the mass number is the sum of protons and neutrons in the nucleus of an atom. As you can see in the image, mass number is A, and atomic number is C, and then X is the element. So we have three different subatomic particles. So we have protons, we have electrons, and as well neutrons. And they all have different charges. So the protons are always positive, as I already mentioned, +1, so E+. On the other hand, electrons are always negatively charged, and they always have E-. And then lastly, neutrons, they are neutral, and they're always 0. And how do we calculate the number of neutrons? We take the mass number minus the atomic mass. So we take the atomic mass number minus the number of protons, because the the atomic number are the number of protons. Okay, so let's do some questions, some simple questions, and I will give you guys a couple of minutes to work on it. Okay, let's go. Determine the number of protons in the following ions and atoms. Okay, so as you can see, we have an ion Mg2+, and we know that the 2+ only affects one thing, the electrons. So it does not change anything else. So the atomic mass, as I already mentioned at the bottom before, still stays at number 12. So Mg protons, 2+ protons, is still gonna be the 12, because nothing changes. The only thing what happens, it loses 2 electrons. So it's gonna have 12 protons and 10 electrons. That's literally it. Okay, so now we have the carbon atom, and as I already mentioned before, something is neutral. Protons and neutrons are, protons and electrons are equals the same. So carbon atom, it has an atomic number of 6, as we can see in the periodic table. So as well, nothing changes. So carbon has carbon protons is gonna be 6. Okay, and lastly, an unknown atom of an element X with a mass number of 63 and 34 neutrons. Okay, so as we can see, the mass number up here is protons plus neutrons. And what we need to find out is how many protons it has. And how do we do it? We take the mass number, which would be in this case, so let's do X, which would be 63, and it has 34 neutrons. So we go on our calculator, we do 63 minus 34, which will give us 29. 63 minus 34, which give us 29. Because the mass number is equals to protons plus neutrons, and since we are given the neutrons, we just have to subtract the neutrons from the mass number, and that will give us 29. Which means if you go on our periodic table, the element with the atomic number 29 is gonna be copper. If they would ask us a question which element this would be, we know the atomic mass number, or the atomic number, is going to be 29, and then we can go on our periodic table and see where it is. Okay, so we got this. Pretty simple. Okay, now I'll give you something challenging here. It's not that challenging, but it's going to give us we have to state how many electrons, neutrons, and as well protons it has. So I will give you guys a second. Okay, So we know that this is a really stable element because it's not an ion, it's not a cation, not an anion. So that means electrons and protons are equal the same. And we know that the protons are 4, so we can write already a 4. And since protons and electrons are equal, we can also write a 4 over here. To find the number of neutrons, we go to our mass number, which is 9. And we subtract it by the number of protons. So it's going to be 9 minus 4, which will give us 5. So the answer is going to be 5. So this atom or this element has 4 electrons, 4 protons, and then 5 neutrons. Okay, now let's go to something challenging. So we have here calcium, which is an ion, 2+, and as we can see, it has 20 protons. So again, we can do our line over here. Oops, sorry. So we know this has 20 protons. But now, because it's an ion, that means the proton and electrons, they're not equally the same. That means they have different amounts. And if an ion is positive, that means we take away from the electron. So that means instead of having 20 electrons, if it was stable, we will take 2 away because it is 2+. So that will give us 18. And to find the number of neutrons, it's gonna be again 40 minus 20, because we take the mass number and we take away the atomic number, which is going to be 20, which is the number of protons, and therefore we get as well 20. Good, that was easy. Okay, so this was a question from a past paper, 2025 to be exact. And the question is, thallium is a heavy metal in group 13 of a periodic table. 30% of thallium atoms contain 122 neutrons and remainder 124 neutrons. They use the nuclear symbol of the isotope of thallium containing 122 neutrons. Use section 7 of the data booklet. Okay, so 7 is going to be the periodic table. Okay, so if you go to our periodic table, where would we find thallium? And that would be number 81. Okay, so we know the atomic number is going to be 81. So we can write at the bottom 81. Okay, what it also gave us, it has 122 neutrons. Okay, we know it has 81 protons. So from there, we do 122 plus 81, which will give us 203. So that means the mass number is going to be 203. Good. That was an easy point for our exam. Good. Okay, so what we then need to know as well are what are isotopes. Okay, so isotopes, so what they are, they have different atoms which have the same element, but they contain the same number of protons and electrons, but the only thing they're different are the number of neutrons. So for example, we have here hydrogen, so we have a normal protium, so normal hydrogen, and then we have deuterium, which is 1-to-1, or it has 1 proton and as well 1 neutron. And that will be different, so it's going to give us 2H1. And then lastly, we have tritium, which will give us 3H1. And what's important to know for isotopes, so they all have the same, or they have the same chemical properties, because nothing changes in the electrons and nothing changes as well in the electron configuration. But because of having an extra neutron, that will change the physical properties due to the different mass number. And it can lead to changes such as in boiling points, melting points, solubility, density, and as well mass. So that is important to know. So I gave you guys a definition of an isotope, and as I already said, protons and electrons are the same. The only thing that changes or differs each different isotope is the number of neutrons. Okay, so now let's go on how to calculate the relative atomic mass. And that is kind of important because a lot of past exams, past papers, they do tend to use it. So what is the relative atomic mass? And it is the mass of an element is the ratio of the average mass of the atoms of an element to the unified atomic mass unit. So it's technically like the average mass of an atom of an element compared to 1/12 of the mass of a carbon-12 atom. And how do we find it? We take the percentage abundance and we multiply it by the mass. Depends how many they are, then we add them all together. And then we divide it by 100 to find the percentage. Okay, so let's, for example, take this. A sample of oxygen contains the following isotopes. 16O has 99.76. 17O has 0.04 percentage abundance, and then 18O has 0.2. Okay, so what do? We do a R, as we did in the other part. Sorry. Let's do this. Okay, so we know that it is the mass is going to be 16. So we do bracket 16 times. And now we put in the percentage abundance, which would be 99.76, close the bracket, we add. Okay, next one would be 17 times 0.04. Let's close it. And now we add the last one, which would be 18 times 0.2, and we close the bracket. And all of this we divide by 100, and this will give us, let's quickly put it in our calculator, 16 times 0.04 plus 18 times 0.2 divided by 100. That will give us 16. That will give us 16%. Yeah. That's it. That's literally all it. 16. Good. Okay. So this was all for the SL part. And now for the HL part, we also need to know the mass spectra and how that works. So how technically the abundance, the percentage abundance of an isotope is measured. And it is being measured by a mass spectrometer, as we can see in the image. So the step-by-step, we also need to know, such as the first step is going to be vaporized, or the sample is vaporized. It's gonna as well it's gonna be ionized, so it's gonna form positive ions, and then it's gonna be accelerated, and only then it's gonna be detected, and it's gonna be detected as mass to change in ratio, which is also known as M/Z. Here's an image, so we can see the sample enters here, it goes through. It's then being vaporized right here. As you can see, it's being vaporized. Then from there on, the ions are as well positively charged over here. So you can see the electron beam as well charges the ions up and turns them positive. Here they're being accelerated. And then here they're gonna be detected right here. And they will be measured in M/Z. Okay, so this is something how the graph will look like, and what we would do to this is literally the same thing what we did before on how to calculate the relative atomic mass. So what we do is we would do I'll give you guys a couple of seconds. We will do 24 times 79 plus 25, times 110 plus 26 times 11 over 100. So if you now put this in the calculator, 24 times 79 plus 5 times 10 plus 26 times 11 divided by 100. That will give us 24.32%. Sorry, I forgot to add the units in the back. I mean, no. Love it. Oops. Okay, that was pretty simple. And now let's go to our last example. I'll give you guys again a couple of minutes or seconds. It's literally the same thing, but with different numbers. So we do 20 times 90.92 plus 21 times 0.26 plus 22 times 8.82. Divide that by 100. Good. Okay, so we do 20 times 90.92 plus bracket 21 times 0.26 plus bracket 22 times 8.82. Divide by 100. It's going to give us 20.179. Good. So what we learned in this specific structure, or the beginning of Unit 2, Structure 1.2, we learned about how to calculate, or let's begin easy. So we learned definitions about the mass number, the atomic number, and as well what are the isotopes or what are the differences, or what differences they have. For example, instead of having different number of this or this, we know that an isotope now has the equal number of electrons and protons, but the only thing they're different is the number of neutrons. So we know that now. Then we also know how to find out the different mass number and as well the atomic number in case. We also looked at the past paper, as you guys remember. We also learned about how to calculate the relative atomic mass. So we have the percentage abundance times mass plus, again, the percentage abundance times mass, depends how many there are, divided by 100. And then lastly, for the HL people, we also learned the mass spectra that isotopes are being detected by mass spectra. And they are the different step-by-step, how they're being vaporized, ionized to positively charged ion, and as well being accelerated and then later detected. And their unit is gonna be m/z. That's important to understand and know, and that was the mass spectrometer. And then we also have looked at the graphs of how to find the relative atomic mass number with the relative abundance and the m/z as we look at the graphs. Thank you very much, guys. I appreciate you for staying with me here today. I hope you have a nice day. I hope this was helpful.